Here, I provide a beam reshaper, that's so-called a Gaussian beam homogenizer here. The polarization of the input Gaussian beam is set to 6. And the width of the Gaussian beam, we can see the profile here, is set to 5 millimeter. So the homogenizer is one piece of lens. It contains 2 surfaces. The first surface is a sphere surface with an initiated radius as 8 millimeters. And the thickness of this lens is set to 1/2 inch. And the diameter of this is set to 1 inch. The terms of the sphere are initiated as all 0. And this piece of lens is 80 millimeters away from the image plane. The image plane size is set as 30, and the illumination area is set as 20 as radius. So the design is through the operand of REAY in the merit functions. So it corresponds the PY, that is the normalized coordinates at the object plane, and to the target plane as the unnormalized coordinate. Okay, so how to do that? Here, let's see here. So the PY is separated into 40 steps. This is the normalized coordinates here. And from this, we can calculate the unnormalized coordinate at the object plane with this equation. So W is the beam width, and this is a polarization factor. So this calculation are shown in this column. And the unnormalized coordinate in the image plane, the calculation is through this equation. And the calculation is shown in this column. So we can see the calculations is shown from here. So we copy these 2 columns, PY and this target, into the merit function editor. So the PY is pasted here, and the target is pasted here. So next we can run the optimization. So before running the optimization, we can look at the profile at the image plane. It's pretty ununiform. So when we optimize it, let's see. Okay. We can see from the targeted area with this negative 20 to a positive 20, it's make it a pretty homogeneous illumination.